Okay, so we're in record mode and we're ready to start. Gentlemen, we must apologize for all the confusion in terms of starting. We would have loved to see you face to face at school. Unfortunately, we've got to wait another week. But teaching can never stop. We must go on teaching and you must go on learning. So we're going to be looking at optimization. And I said I'm going to start off with some revision questions and then go on to something new. So when we look at optimization, we're looking at maximum, minimum, how high, how low, or how large is something possible, which I think you have the background to. But I'd like to represent the cubic graph. If we look at the cubic graph, I'm sure you had the opportunity to draw the cubic graph. And it's coming up on your screen. If we look at the first turning point, we would call this a maximum turning point. And we know that the derivative is the gradient at a point. So the gradient at this turning point is 0. So our conclusion is at a maximum or a minimum, the derivative is equal to 0. Now that is very important for you to take into the section. That whenever we're talking about a maximum or a minimum, what we got to do is find the derivative and equate 0. So from the graphs, you know, we have a local maximum. We call them the stationary points as well. And I want to leave you 3 points that you need to write down. Whenever we're going to be dealing with maximum or minimum. Point 1, you're going to find the derivative and you're going to equate to 0. Point 2, then we're going to solve for x. And point number 3, depending on the question, we will sub x back into the original equation, which is the f of x and not the derivative, to find the maximum or minimum. So let's go to our first question. In this question, the edges of a rectangular box that you can see on the screen. And they tell us that the dimensions, we have the length is x, the height is x, and the breadth is 240 minus 2x. The first question wants you to show that the volume of the box is given by v is equal to 240 x squared minus 2x cubed. The first thing I want you to write down on your page is write down the formula for volume of a rectangular box. Mr. Parsons, are you with me?
Yes, sir.
You're going to tell me when you finish writing so I know what speed to work with. Is that okay, yes. Parsons?
That's fine.
All right, Parsons. So if we've done that, we know the volume for a rectangular box. It's very simple. Length times breadth times height. Now we're going to substitute the length, breadth, and height. Quickly do that. And you should be getting x times x into 240 minus 2x. So we're going to multiply x times x is x squared. And then we're going to use the distributive law and multiply into 240, which gives us 240x squared. And the x times x, which is x squared, times minus 2x, would give us minus 2x cubed. Parsons, did you get that?
Yes, sir.
All right, we're ready to move on. The question now states, find the maximum volume of the box. So remember the notes I told you to write. Whenever we talk about maximum and highlight this word maximum or write it down, we will find the derivative and equate to 0. So I want you now to go find the derivative of this expression. Parsons, let me know when you got it. Did you get it?
Yes.
Done?
Yes.
Yeah, so if we find the derivative of this, remember the rules for differentiation, 240 times 2 And that should give us 480x. Minus 2 times 3 is minus 6. And remember, we decreased the exponent by 1. So x cubed becomes x squared becomes x. So we found the derivative. Remember the note for maximum, you find a derivative and you're going to equate to 0. Now what I want you to do is go and solve for x. And to give you a hint, you can do it two ways. You can divide the expression by 6 to simplify it first, or you could directly pull out the common factor. So we are factorizing at this stage. Mr. Parsons, are you done?
So give me like 10 seconds.
Okay, thank you.
Done, sir.
All right, so we're gonna pull out, I'm gonna pull out a common factor, which is 6x. Or you could have divided by 6 first, and then you would just pull out x to be a common factor. Whichever way you go, it's fine. And then we're gonna say that 6x is equal to 0, or 80 minus x is equal to 0. And from there, we can state that x is 0, or if 80 minus x is equal to 0, then x will give you 80. Now we have two answers because it is a quadratic, 0 and 80. But looking at our box, we kind of have a box with a dimension of 0. So 80 would give us our maximum. So we're going to accept 80 as our answer. But remember the question says find the maximum volume. And from your notes, I gave you 3 points. Number 1, we find the derivative equate to 0. We solve for x. And point number 3, we need to sub this 80 into the volume formula. And this is the volume formula. So I want you quickly to substitute 80 into this formula. Mr. Parsons, what answer did you get?
Yes, sir. So I'm busy doing it, sir.
Okay, I'll give him some time.
So I got 512,000.
512,000. Let me see if I'm getting that. 512,000. Okay. Remember, in this session, I don't want you to watch a movie. I want you to be a participant and not a spectator. Therefore, I want you working with a page. Is that okay with you guys?
Yes,
Right.
sir.
We're moving on to question 2. And there were a lot of questions, this question which was given in the activity, so I'm revisiting this. It says a rectangular box is constructed in a way such that the length of the base is 3 times. Let's ponder over that. The length is 3 times as long as its width. The material used to construct the top and the bottom of the box cost 100 Rand per square meter. The material used to construct the sides of the box cost 50 Rand per square meter. The box must have a volume of 9 meters cubed. Let the width of the box be x, which they've shown us in the diagram. The question is determine the expression for the height of the box in terms of x. The first thing I want you to do is write down the expression for volume, or the equation for volume. All right. And we all know it's length times breadth times height. In the actual question, I want to highlight 3 times. So if the length is 3 times the width, we can conclude that the length is now equal to 3x. If that's x, that's 3x. So going into the formula you wrote down, volume is equal to length times breadth times height. I want you to quickly substitute the length, the breadth, and the height into the formula. Let's see what you get. So substituting length, breadth, and height. Remember the length is 3x. the breadth is X, the height we don't know, so we leave it as H, but they did tell us that the volume of the box is 9. So we are replacing or substituting 9 for V. Now what I want you to do next is to solve for H, because that's the question. So to do that, we're going to say 3x times x is 3x squared times H. And we're going to divide both sides by 3x squared. And if we do that, 9 divided by 3 is 3. So I'm dividing by 3 first to give you x squared to the h. And then I'm going to divide by x squared. And I end up with 3 over x squared. And that was a question. Find the expression of h. That's your height. In terms of x, which means your answer should have x in it. All right, we're moving on to... yes.
So can I ask a quick question? Where would we find this material in our books? I'd like to follow along with the explanations in the book.
Okay, what I will do for you, I will make this PowerPoint available. This was about 3 weeks ago. The work was given on optimization. So the question is on that handout. But who am I talking? Who's your maths teacher?
Ms. Daisel, sir.
Yeah, you can just tell me maybe to forward it to you via a team, but we have put it out there. And it should be on the Moodle as well. So we can make it available to you. Just give us a reminder because we may do it after this lesson. Right. So moving on to 2.2. Now it says show the cost to construct the box. So we're talking about money, some money, right? How much it's going to cost. Now remember, if we are making this box, we're not interested in how much it can take. We're not interested in volume. So we need material to make the box. So we're looking at surface area. So I want to remind you of the dimension. So the first thing we want to start off is, what is the formula for surface area of a rectangular box? Now I'm going to explain the formula if you don't know, but let's look at it as rectangles. This box has 6 faces, which have 6 rectangles. And remember, each face, there's 2 of each face. So if we look at the front view, there's 1 in the front and 1 behind it. There's a side view, so there's 2 of these rectangles, and there's a top view. So let's start off with the top view. To find the area of a rectangle is length times breadth. We all know that. So to find the top rectangle, the dimensions is L times the breadth. But because there's 2 of it, so we say 2 length times breadth. To find the front view, it's length times height, which you can see in the formula. And to find the side view, it's breadth times height. And remember, 2 of each. Now we're going to substitute the values given in the diagram. So the length is 3x, the breadth is x, and the height we found in the previous slide. So let's put it all together. Length, remember, is 3x, the breadth is x, the length is 3x. Remember your height we found in the previous slide, your height was 3 over x squared. Plus 2, breadth is x, and your height is 3 over x squared. Sorry, I'm moving too fast. We have some latecomers joining us. I think they need a detention for coming late to class. But we'll apply some grace for today. Welcome, Mr. Kuzwayo. Welcome, Mr. Kuzwayo, who's just joining us very late in the lesson. All right, Mr. Parsons, I'm waiting for feedback from you. Have you managed to work this out?
So can I pass it on to someone else, sir?
Why not?
Yeah, I'm a bit stuck, sir.
Put somebody else under pressure. Mr. Tenjwayo, can you put your mic on? Mr. Tenjwayo and Mr. Answad. I think I'll have two in case one is sleeping. Mr. Answad and Mr. Tenjwayo, can you join us on the discussion? Now, 2 times 3 is 6. So, I'm going to simplify this. 2 times 3 is 6x squared. 2 times 3 is 6, and there's a 3 on the top, which gives us 18. We can cancel the square with the x, so it's over x. 2 times 3 is 6, canceling the square with the x, that's over x. So we have our expression for area. Are you happy with that, Mr. Answad?
Yes, sir.
Well done.
Angus.
Now remember, we can simplify this expression because we have a common denominator to be x. And 18 plus 6 is 24 over x.
Oh.
All right. Are we happy to move on? So now
Yes, sir.
we need to return to the question. We have the area of the box in terms of x. And the question says that the material is used to construct the top and the bottom of the box costs 100 Rand a square meter. Now, which part of our formula is the top and bottom? If you remember when I was explaining the formula, 2 length times breadth, this is the top part, which gave us 6x squared, which means we should be multiplying this by 100. And the rest of the box, the side view and the front view were these two parts, which worked out to be 24 over x. And we're going to multiply that by 50 because that's what the question says. Only the top and the bottom is 100 Rand per square meter. So we're going to multiply 6x squared, multiply by 100, 24 over x times 50.
Sorry, sir. I'm a bit lost on the 100, sir.
The question tells us, let's return to the question. The material used to construct the top and the bottom of the box costs 100 Rand a square meter.
Yes, sir.
So the top and bottom, in terms of square meters, is 6x squared.
Yes, sir.
Because the top and bottom is length times breadth, which was this part of the equation, which comes out to be 6x squared. And the rest
Yes,
of
sir.
the box, 24 over x, which is calculated at 50 Rand a square meter. Okay, we're ready to move on.
Okay.
We're going to multiply this out. Yes, Mr. Tenjwayo, what did you get if you multiply this out?
Yes, sir. I was lost, sir, so I haven't done it.
Okay. I thought you're working with me and you're not a spectator now.
So I'll have it now.
Okay. 6 times 100 is 600x squared. And 24 times 50 is 1,200 over x. And you see, that's what the question wants us to actually get. The order is just different from that, but it's the same expression. Answer what you with me.
Yes, sir.
Okay. So write down, if you're not with me, it's fine, but write this down. I mean mentally, not physically or online. If you're not with me at this stage, write down the cost formula because we need it for the next question. We will make the video available so you can go. Because of time, I'll have to move on. We can't take too many questions, but we will make the video available to you. So moving on, the next question is to calculate the width of the box if the cost is to be a minimum. The word minimum, immediately, what should be ticking in your brain? Find the derivative equates to 0. So remember, we're working with cost. So what was our cost formula? Very quickly, I want you guys to find the derivative. I hope you remember how to find the derivative. So let me help you out. The first thing we're going to do is simplify this function. Take your x to the top. It becomes x to the negative 1. Now we're going to find the derivative. I'll give you some time. Answat, am I moving too fast there?
No, sir. It's fine.
Is my first team rugby captain with us today? First team soccer captain, Goodacre. First team soccer captain, this place, is he with us today? Oh, look like the sporting heroes are still sleeping. All right. So we're going to use a derivative, and 600 times 2 is 1,200. The power decreases by 1 to be x. 1,200 times minus 1 is negative 1,200x. And remember, minus 1 is negative 2. So we find a derivative. Now we're going to equate to 0. And the next part is to solve for x. So x to the negative 2, we need to take it to the bottom. And it becomes 1,200x minus 1,200 over x squared. So there's different ways to work it from here. We can find a common denominator called x squared, or we could take this on the other side and do some cross multiplication. Whatever you're comfortable with. Let me give you some time for that. Okay, so moving on. I found a common denominator of x squared. So I multiplied this by x squared, will give me 1,200x cubed. And if I multiply this expression by x squared, we're going to have minus 1,200, which is equal to 0. Next, we're moving the minus 1,200 on the other side, becomes plus. Divide both sides by 1,200. You got x cubed to be 1. Finding the cube root of x, and that should give me 1. The question is calculate the width of the box. So we found the width, which is represented by x, is 1 meter. If the question was calculate the minimum cost, then we'll take our 1 and substitute it into the cost equation. But that is not the question. So I'm ready to move on. Mr. Answorth, are you ready to move on with me?
Yes, sir.
Just give me a minute. Come on, Mr. Lumen. Can I just come back to you? I'm just on a live session to Form 6. Okay, so we're moving on. And sorry, I had to take an urgent call from the headmaster. So we got x is 1, and we're done. We're going on to question 3. So we're going to a cylinder. Let's swap now. Let's give Answorth a break. Let's bring in Mr. Jackson. Are you with us?
Yes, sir. I'm here, sir.
All right, Jackson. You can give me feedback on this one. The radius of the base of a solid. Okay, and you have a cylinder. The radius is x. The height is 300 minus x. The question is, show that the volume of the cylinder. So we want to start with the volume. What is the equation for volume of a cylinder, Mr. Jackson? What is the volume?
Power squared times height.
Top man. Can you guys see that? He's got a good maths teacher, that guy. Right, so volume is equal to pi r squared times h. They're telling us that our radius is x, so we're going to substitute x. We've got the height, which is 300 minus x, so you're going to substitute. Let's give you some time, quickly substitute. All right, if we substitute, we got pi, x squared and 300 minus x. We're now going to use distributive law and multiply this out. And that should give you 300 pi x squared minus pi x cubed. Jackson, does that make sense so far?
Yes, it does.
Okay, so we got what they want. The next question is to find the maximum. Now I'm going to once again focus on the word maximum. Remember, find the derivative, equate to 0. and solve for x. So I want you to get a head start. So if we find a derivative, it's 300 times 2, which is 600 pi x. Power drops by 1. 3 pi x squared. So we got our derivative. Next, we equate to 0. Now remember, we can simplify this function by dividing by the constant. You'll notice 3 is common. Also pi is common. Remember pi? Some of you may be getting hungry now. Pies are very unhealthy, so don't go for pies for the morning. Have your Kellogg's. We want to divide the expression and simplify it by 3 and then by pi, which gives us 200x minus x squared. Remember, 600 divided by 3 is 200. Divided by pi, going to cancel off. 3 divided by 3 is 1, and pi divided by pi. So I divided by 3 pi. Next, we want to solve for x, and to do that, we're going to factorize. Give you a hint, common factor. What did you get, Mr. Jackson?
I'm still working it out too.
Mr. Danilal, we have Mr. Danilal. We'll use Mr. Danilal to join us for feedback next. Mr. Danilal, can you turn your mic on there?
Yes, sir.
All right. Give us some input as we're going along. Mr. Danilal, did you manage to factorize this?
I know, sir. I just joined up right now, sir.
Okay, Mr. Danilal, turn your mic off. We'll be a little lost. We need somebody who's joined us from the beginning.
Morning, sir. I've got a question. Earlier on, you divided by 3 pi. Couldn't you have also divided by 1x, sir?
You can't divide by a variable, because if we divide by a variable, remember this is a quadratic, we're going to lose one of the answers. We'll then change it to a linear function. Remember in a quadratic, we want to get 2 answers. So when you solve for x, you're not allowed to divide by x because you will lose one of the roots. Okay, no go zone. Remember that in future.
Okay, thank you, sir.
Okay, so if we pull out x to be a common factor, we'll have to 200 minus x. We have 2 answers. Remember, it's a quadratic. So x will be equal to 0 or x is 200. So putting the answers in context of the diagram, we can't have a cylinder with a radius of 0. Neither can it be negative, so we will accept 200. So Mr. Jackson, what are we going to do next?
Sub that x or sub the 200 into the volume formula.
Brilliant.
Okay,
Brilliant. So we're going to take, because it said find the maximum volume, we're going to take the 200 and substitute in the volume formula. Let's give you some time to do that. I see we have Mr. Brains. Mr. Brains, would you like to join us?
Yes, sir.
Mr. Brains, what a beautiful name. What a brainy character we have with us today.
Wow.
Mr. Brains, did you get an answer here?
Yes, sir. I got 125,663, or like 125,66370,61.
Now, gentlemen, we work smart on our calculators. That's what Mr. Brain is doing, all right? We're just typing 300 pi, just as what you see, type it in your calculator. I'm getting 4 million, so my answer, I have a calculation problem there.
Oh, yes, sir. Must have calculated wrong, sir.
Yo, Mr. Jackson, just type it in your calculator. Tell me what you're getting.
No, so there was an error in this PowerPoint. I remember what it did.
Sir, I got the same as Brain, sir. That big number. Sir.
Okay. So can you call out your answer?
So 125,66370,61, sir.
So I'm not going to put up my answer there, right? Okay, I can write it down. just to show you guys that, let me just get my,
12 million.
okay, Mr.
Yeah,
Jackson,
that's the one.
the answer is 1,
So 12 million
12
and
million,
566,370.
566, 3,
370,
okay,
comma
guys,
61.
we're getting 12,566,370.
Yes, that's it.
You must be able to read big numbers because later on in life you're going to be earning big salaries. And if you can't read your own salary, you're going to have problems. So make sure you can read big numbers. All right. So my
So,
calculator deceived me. Let's move on.
so can I ask a question? So,
Go for it.
so when you originally trying to work out the volume of a cylinder, so do you have to know the actual volume of a cylinder, or will they give it to you in the paper? So
Nothing in life is guaranteed. Sometimes they give it to you, sometimes they may not. They're not obligated to give it to you. So my answer to that, you learn the formula. Okay.
oh yes, sir.
But remember to find the volume of your standard shape. It's always the area of the base. The area of the circle is pi r squared. So it's the area of the base times height. Are you understanding the formula? So to find
Oh
a
yes, I am, sir.
cylinder, area of base, so area of circle is pi r squared times the height. Okay.
Sure.
Data is expensive, so I need to move on, guys.
Yes, sir.
Let me just delete that from the screen. Okay. This is quite a difficult question because it's not broken down for you. So it was quite challenging with most of my boys. So it says a drinking glass in the shape of a cylinder must hold 200 mils of liquid when full. Find the value of R for which the total surface area of the glass is a minimum. So let's try and understand what is given. It must hold 200 mils. Mr. Brains, what does that tell you?
So isn't 200 milliliters also the volume, sir?
Brilliant. So the 200 mils is talking about not surface area, it's milliliters talking about volume. So I need to start off with the volume formula. So the volume of a cylinder, now we did this in the previous slide, is pi r squared h. Now remember, the question is to find r for which the surface area. So next I'm going to bring in the surface area formula. But I'm starting with the volume is because I'm given the volume. So what we're going to do is we've got two unknowns here. We've got R and H. We need to find R in terms of H.
Wow, sir.
Sorry, I said that wrong. We need to find H in terms of R. And the reason is, later on, I should have put the surface area formula up for you. Okay, later on we're going to substitute that value of H into the surface area formula so that the surface area formula will only have an R in it. We can't have two unknowns to solve. Okay, I'll come back to that point. Just stay with me a little while. So we know the volume is 200. So I'm going to substitute that, which is equal to pi r squared H. So what I want to do now is I've got two unknowns. I want to get rid of H, so I'm going to solve for H. And if I do that, I'm going to divide both sides by pi r squared. So we know the height is equal to 200 over pi r squared. So we found H in terms of R. And the reason is, so when I come to surface area, I can replace H in terms of R. Does that make sense for you at this stage? Mr. Brains?
Yes, sir.
Yes, sir.
All right, so let's go to the surface area formula. Now, what is a surface area formula for a cylinder? So let's inspect the shape. There are two circles. There's a circle in the bottom and a circle on the top. So normally it will be 2 pi r squared. But remember, this is a drinking glass and it does not have a top. So therefore, we're dealing with one circle, pi r squared. Plus, and if we open out the part, we get 2 pi r h. So we have the surface area of a cylinder, the glass, which is in the shape of a cylinder, is pi r squared plus 2 pi r h. Now, we want to find r. The problem is we have two unknowns. Remember pi, don't worry about pi, it's a constant. If you want, it's 22 over 7 or 3.14, but we leave pi as it is because the calculator has a button called pi for us. So we're going to replace this h with 200 over pi r squared so that we only have r in the formula. So if we do that, h is equal to 200 over pi r squared. And I want you to simplify that, so I'm giving you some time. Pi and pi cancels, r will cancel with the square. And you should end up with pi r squared plus 2 times 200 is 400. Remember the pi cancel and the r with the r squared all over r. Do we have a Mr. Fenter with us today?
You
Hello,
do, sir?
Mr. Fenter. Mr. Fenter, what are we going to do next?
I kind of zoned out for a bit there, so I'm not sure.
Okay. We have a Mr. Let's bring someone new. We have Moses with us. Is Moses with us? Moses?
Yes, sir.
What are we going to do next, Moses?
Gonna hit the derivative, sir.
Well done. Remember the question said find r for a minimum. So we're going to find a derivative and equate to 0. Thank you, Moses. Now,
Thank you.
if we find a derivative, Moses, can you give us a derivative?
2 pi r minus 400 r to the minus 2.
Okay, he simplified the function first. He took r to the top, he got r to the minus 1. And from there, he's got, okay, from here, we're finding the derivative, which is 2 pi r, as Moses told us, 2 pi r minus 400, and you decrease the power by 1, which gives you negative 2.
Yes, sir.
Mr. Foster, are you with us?
Yes, sir.
Welcome, Mr. Krunefeld. He's just joined us. All right, Mr. Foster, we're going to equate this to 0. Am I right?
Yes, sir.
Well done. Now, we're going to simplify the function by taking r to negative 2 to the bottom. Actually, I divided by 2 first, just to simplify this. I'm dividing right through by 2. I'm getting pi r minus 200 r to the negative 2 is equal to 0. I took my r to the negative 2 to the bottom. Gives me r squared. Mr. Foster, are you coping? Am I moving too fast now? All right. So from here, we're going to find an LCD, which is r squared. You can put this over 1. Your LCD is r squared. So we multiply this side by r squared. We get pi r cubed. And on this side, the r squared will cancel off. We're getting minus 200. Taking our minus 200 on the other side, we'll get a plus 200. We're dividing both sides by pi. We get r cubed to be equal to 200 over pi. And we can type this on the calculator, find the cube root. Before I release my answer, Mr. Foster, what are you getting?
I'm working on it, sir.
Mr. Bengu, are you with us, Mr. Bengu?
Yes, sir. Yes, sir.
What answer are you getting, Mr. Bengu?
I'm still calculating this, sir.
Okay, we have a Mr. Modley with us. Mr. Modley, D. Modley, do you have an answer?
Yes, sir. I got 3,992.
All right. So if we find a equivalent of that, we're going to 3.99. Well done, Mr. Woodley.
Thank you.
So it was quite a tricky question because you see, they didn't break this question down for us. But the previous slide helped us a little to get into this question. Now, my last question is on a cone. And I'm going to stop. I'm not going to go to the cone. I will cover this on Thursday. All right. Because time is up. We've been online for 45 minutes. Data is expensive for some of you, so I don't want to limits. Can I just have some feedback, 2 or 3 gentlemen?
Yes, sir.
Fun, eh?
Okay, gentlemen, for future, anything we can do on our side to improve this? I'm talking about the actual lesson, Zoom lesson. Any pointers from you, or you think you understood it?
That was good, sir.
It was
That
good.
was good.
Yes, it was good, sir.
Good,
Oh,
sir.
sir, it was great, sir. It was very good, sir.
Yeah, no,
Helpful, sir.
Top, sir.
Actually, will definitely take you somewhere in life. But what I want to say is, anything else that we need to change? What hassles are you having from your side? Are you having any problems?
Just a connection, sir.
Just the connection.
Yes, just the connection, sir.
Yeah,
Data's a struggle.
yeah, the networks are struggling because you guys at home playing Xbox Live.
I know, sir. We're in the Zoom, sir.
No time for that, sir.